Welcome to another screencast. This one is going to be talking about warm fronts, and just like the cold front, we're starting with your textbook picture of a warm front. You can see it's kind of like a hybrid. It has the map symbols right over here, which look like half suns, warm front, red. And you can see that the warm air is rising above the colder, denser air. So basically, when you're looking at a warm front, you have to realize that warm air doesn't really have a shape. How sad. Isn't that sad? Maybe it should join a gym or something. It takes a shape around cold air. So cold air sticks to the ground, and just like in a cold front, which we already talked about, we have the cold front is right over here. We have the faster moving cold air over here, and then this is the receding air. That's the slower air right over here. This is slower moving cold air. So this is just a quick little reminder of what a cold front looks like. See, my continental polar air mass is colliding with my maritime tropical air mass over here, giving us the cold front, heavy precipitation over a short period of time. That's the cold front. So you can basically start this little editing of a cold front to make it a warm front. First things first, change it to warm, as in warm front, and then change the color to make it red. And then what you would do is you would get out a pair of gigantic scissors, and then you would cut the cold front. Doesn't hurt at all, kind of like cutting your hair. And what you wind up with is, this is what the warm front looks like. So you're looking at the warm air catching up to the slowest moving cold air in a cold air mass, way this direction, miles and miles and miles, hundreds of miles, thousands of miles sometimes. You would have the cold front would be way over here. So all you're seeing in a warm front when it's drawn typically is just the tail end of the cold air mass that this warm air is catching up to. So this faster moving warm air is catching up to the slowest moving cold air of a cold air mass. What winds up happening is that warm air still goes above the cold air because the cold air is denser, the warm air is less dense. So it goes up this little gentle ramp, and you wind up, instead of getting tall clouds, you wind up getting thin spread out clouds over a warm front. So you get light precipitation over a long period of time. That's what the blue is supposed to represent, precipitation. And that would be a warm front. Light precipitation over a long period of time is characteristic of a warm front. Map symbol wise, this is looking at it from above, overhead. So here would be my warm front, map symbol for it. My maritime tropical air mass is behind it. My continental polar air mass is in front of it. The cold air is in front of it. And the map symbols are drawn on the side in which the front is moving. So this front is moving to the right. And if we shaded the area of precipitation, it's a much larger area of precipitation than the cold front, and it occurs in front of the front itself. And if you look back over here, you can see that's where the precipitation pattern is. So you're in the warm air mass over here, but the precipitation is happening in front of it. And if we looked at these three cities, city A, B, and C, which again took me an eternity to come up with again. When this warm front moves, and it's going to move in this direction, the cities don't move, you would see that city C right now is currently experiencing light precipitation. A is starting to get light precipitation. It's going to get light precipitation over a couple of days as the front moves out. And now eventually C would be in a warm air mass. It's no longer in a cold air mass. So C's temperature would increase. Its barometric pressure would decrease as the front passes, right? You would see it just keep moving along this way. We look at, here's another textbook rendering of a warm front. You can see that it's a much more gentle slope than a cold front. The clouds get spread out, light precipitation over a long period of time, and you can see you're even getting snow here because this cold air that the precipitation is falling through is cold enough to give us snow. And this slide here is also showing you another textbook rendering of a warm front. The important thing to note is that it's a much more gentle slope than a cold front. The clouds get spread out over a larger area. Therefore, the precipitation occurs over a larger area, and it's usually over a number of days. Light precipitation over a long period of time. And that pretty much covers what a warm front is. So now you know what a cold front is and a warm front, so you know what time it is. Yep. That's right, it's time to get out the gigantic human hamster ball and go bowling. It does look like a lot of fun, doesn't it? Someday.